I don't know if you guys remember when you started adding and subtracting fractions, the denominators have to be the same. Okay, they got to be the same. And when you finally do get denominators that are the same, do you add them or subtract them? Do I get 5 over 14? No. You keep the denominators the same. Once you get like denominators, you keep them the same, then either add or subtract your numerators. Okay, so keep that in mind as we're adding these fractions. So what's convenient already about number 1?
Same denominator.
Oh, perfect. You don't have to do a thing. Same denominators. So what should be my denominator and my answer?
2C.
There you go, 2C. I keep it the same. Do not add the denominators. Once you have like denominators, keep it the same. And now I add my numerators. Is there really much I can do with x plus y plus z? Nope, nothing at all. But I'm going to write it though. X plus y plus z. Can I factor anything? That you do have to look to reduce at the end. All right, can I do anything? Nope. X plus y plus z, nothing to take out, and I certainly can't do anything with the 2c. So that's as far as I can go there. Yep.
Can you put x, y, z?
No, that's multiplication. Right? We're adding them. All right, x, y, z would be multiplying them. Number 2, you got like denominators?
Yes.
Okay, so what's your final answer denominator?
X minus 2.
What are we writing on top?
5x minus 10.
Everyone all right? 5x minus 10? Nothing you can do there, but unlike the last one, we're not done here. Okay, we're not done. You combine your like terms, just did that, write it over your denominator, did it. Now, why am I saying I'm not done here? I can keep reducing. Why? What's up in the numerator here? Don't say anything. Here we go. What's up in the numerator? 12. Zach, what's up in the numerator? GCF. What is it?
5.
5. What's left?
X minus 2.
Anything you want to keep going?
Cross
Or
out the X minus 2.
I can cross off. This is just simplifying. We did a whole week on this now. Cross off the x minus 2, so my final answer
5.
is 5. Right there. I think that might be the toughest part, is remembering I have to see if I can reduce or not at the end. Any issues? All right, here's where I'm going to start getting a little fired up, coming here on the next one. All right, get ready. Any issues with the denominators? They're both the same, perfect. X squared plus 3x on the bottom. Okay, here's where I'm going to get fired up a little bit. What am I doing to these two fractions? I'm subtracting them, aren't I? You have to be definitely aware, focused in when you subtract. Here's why. On top, you're going to do 2x squared minus x squared, and everyone's just going to write plus 9. No. Hey, when you're subtracting, this negative goes to the entire second fraction. So not only am I going to do minus x squared, what else do I have to do here? Minus 9. When you subtract, that subtraction symbol belongs to everything in the second fraction. So not only is it minus x squared, but it's also minus 9. That's going to be a tough one there. When I subtract, I got to make sure I distribute that negative out front. Now combine your like terms. Combine your like terms. What are you going to be left with in my numerator? In my numerator, 19. Lauren, what's left in the numerator?
2x squared minus.
You got 2x squared minus x squared. So you can combine those because they're both x squareds. I got 2 of them minus 1 of them. How many are left? 1x squared. And what's still there? Minus 9. Everyone all right where we got that? 2x squared minus x squared is x squared. Over x squared plus 3x. Keep going because that's not done yet. That's definitely not simplified. Jeremy, keep going. What can I factor?
If you factor x squared minus 9, and you get x plus 3 and x minus 3.
Yep. Is that it?
You can also factor x down the x
Yep.
squared plus 3x.
That's a GCF. Keep going.
And then you can cross out the x plus 3 on the top and bottom.
Good. And then here we go with our final answer. X minus 3 over x. Can I cross off the x's? Anybody cross off the x's?
Yes.
These x's right here, cross them off.
Yeah.
What's on top? Subtraction. Can't look. If you're here, here's the bottom line, guys. If you're gonna cross off the x's, then you got to do something with the 3 as well. You can't just cross off one and leave the other one hanging. Okay, so the answer there is we are done. Go ahead, try 4 on your own. See what you can do with 4. You already have like denominators. Combine your like terms. What do you end up with on top? Combine your like terms. What do we end up with on top? Elizabeth, what'd you end up on top when you combine your like terms?
3x plus 9.
Yep, 3x plus 9. From there, what else did we keep doing? Ooh, got everybody today. Sarah, what do you keep doing here? What are you going to keep doing here?
Can you factor the bottom?
Go ahead.
You're going to end up with x minus 8 and x plus 3.
Good. Not even going to go over why or how she got that. We're way past that point. And
You can take out a 3 from the top.
yep, and be left with
X plus 3.
x plus 3. Yep. You want to keep going?
You can cross out the x plus 3.
There you go. So final answer.
Over 8.
Over what?
8 minus x.
8.
8x minus 8. I'm sorry. No.
What's left on the bottom?
Is that x minus 8?
Good.
Is it fine if you leave the x minus 8 in parentheses?
Fine with me. Yep. So really the only issue we're having so far is we got to remember if we're subtracting, we got to distribute through the second fraction. Okay, anything I can answer for you guys right now? Because as you guys can see, the next one changes a little bit. So we gotta slow down. Anything when the denominators are the same. Only thing you gotta watch out for, make sure you distribute the negative. All right, ready? What's the problem with the next one?
You're not like
Okay, they're not the same, but we need to make them the same. All right, we need to figure out the smallest denominator that both 4x and 8x go into. So I'm going to start with the numbers 4 and 8. Smallest number both go into.
Yep.
Both 4 to 4 doesn't go into 2, 8 doesn't go into 2.
4 goes into 8.
I'm looking for the smallest number both 4 and 8 go into.
4.
Smaller than 16.
8.
8. 4, yeah, 8. Some of you guys are saying 4, but 8 doesn't go into 4 evenly. Okay? It's going to be 8. 4 and 8, the smallest number that they have in common is 8. What else do they have in them that I have to pay attention to?
Nice.
X's. Do they both have X's in them?
Yes.
Okay, then that's going to go in my common denominator too. So there's your common denominator, 8x. Okay, now where do I go from here? 4x. What do you need to multiply 4x by to get your common denominator of 8x? 2. So that is what you're going to multiply the bottom, which we already did, and the top by. So instead of putting a 3 here, what am I going to put? A 6, correct. So that's going to be a 6 on top. And I already took care of this. 2 times 4x gave me 8x. All right, what do I need to multiply 8x by? Nothing, 1, right? So that's what I multiply the top by. So minus 6 minus 3. Final answer, 3 over. Anybody want to try to do anything? 3 over 8x? No, there's nothing there. Now, I will, if you still feel uncomfortable about picking a common denominator from two numbers like the 4 and the 8, the easy way out is just multiply them. So you could have put 32 here, but I will warn you, you're going to have to reduce at the end. So that's up to you. Okay, the easy way around it is you can just multiply the numbers, write it. So 32x instead, but you would have had to reduce. All right? All right, 6. Not common denominators. Let's take care of the numbers. What are the numbers in the denominators? 2 and 1. Okay, what's the I don't think we have to go too far here. Common denominator, 2 and 1. Just 2. What do they both have in them now? Okay, but one's got an a squared now. You always take the one with the highest exponent. You take the one with the highest exponent. So a squared and a, the common denominator between those is a squared. You take the one with the highest exponent when we find common denominators. So there it is, 2a squared. All right, let me turn it over to you guys now. I'll go slow here. I'll get somebody here sooner or later. Maybe not. There we go. Mike, here you go. What must I multiply a squared by to get my common denominator of 2a squared? 2. So multiply top and bottom by 2. So instead of 5, Mike, what am I going to have in my denominator, my numerator first? 10. Good job. What do I need to multiply 2a by to get 2a squared? Ooh, there we go. Sarah, back to you. What? They don't look the same, though. Like here, it was 8x and 8x, so I multiplied by nothing, basically. But this is 2a and a squared, 2a squared. A. There you go. So I'm going to multiply the bottom and the top by a. So I'm not going to subtract 3, Sarah. What am I going to subtract on the top? Minus 3a. Thoughts, if I can go further? Can I cross off an a with the a squared? I don't know. I'm just 10 and 2.
It's a minus.
Correct. If I cross out something here, I got to cross out something everywhere. So that minus says, nope, stop, you're done. Next one, see if you can find the common denominator yourself on the next one before I ask. XY squared, X squared, Y squared. See if you can find what the common denominator is there. All right. Okay, Elizabeth, what do you think here? They both have X's in them. So you take out the one with,
Well, what I did was multiply the first
well, hold on. Don't multiply yet. I need to know what my common denominator is before I multiply yet.
I didn't say yet.
Okay. Do they both have X's in them?
Yes.
Okay. So do I write X or do I write X squared?
X squared.
X squared? Do they both have Y's in them?
Yes.
So which one do I write in? The Y or the Y squared? You always use the one with the highest exponent. So my common denominator, X squared, Y squared. We're all good, kids? All right, take a look at your first denominator, XY squared. What do I multiply to get X squared, Y squared? What do I have to multiply that denominator by to get X squared, Y squared on the other side? Take our time here. Let's take our time. Running. Okay, Elizabeth, back to you.
X.
Good job, X, because the only thing I'm missing is the squared. So multiply top, bottom by X. All right, what am I going to have to do with this X now? Distribute. Distribute it. Here we go. Boom, boom. I got to distribute it. And what happens when I distribute it? What do I get on top now? Let me get there, maybe. Lauren, what do I happens when I distribute?
X squared minus YX.
Good job. X squared minus YX, XY, both are the same, mean the same thing. Take your time. Next one, next fraction. What do I have to multiply top and bottom by to get the common denominator? Frank? Y. Good job. So multiply top and bottom by Y. Again, distribute the Y, just like I distributed the X in the last one. What do you get when you distribute the Y? Hopefully we're all right here. Oriana, what happens when you distribute the Y?
Plus YX plus Y squared.
Good job. Plus YX plus Y squared. There you go. Good job, guys. So there's my new numerator. Anybody see anything that happens in the numerator when I combine?
You have like there.
I do. And what happens to them?
They cancel out.
Negative XY, positive XY. See you later. So I have X squared plus Y squared over X squared, Y squared. Ooh, boy. We're going to have a little heated debate here, huh? Is it possible to go further?
No.
I hear a no.
No.
Another no. Is that different to two perfect squares on top? Nope, because I'm adding. Can you get rid of the X squared, cross off the X squareds, cross off the Y squareds? No, there's a plus sign there. So the answer is yes, there's nowhere you can go. We're done. Whew. Questions before we get to the last one, and then you're on your own. This one's going to be a little tricky. That's why I leave it to the last one. Do I have the same denominators, first of all?
No.
No, absolutely. Those are not the same. Notice anything about them for what we've been talking about the last week and a half now? C minus 5, phi minus C. Those denominators are opposites, aren't they? They're opposites. Okay, so if I have two denominators that are opposites, you are going to make them look the same first. How am I going to make them look the same? you are going to take a look, take out a -1 from one of them. I always take out a -1 from the one that's written backwards. You're going to take out a -1 from one of the denominators if you have opposites. Watch what happens. I got take out a -1. So you're dividing everything, the 5 and the -c by -1. Take out a -1. What's going to be left inside your parenthesis now? After you take out a -1 from 5 minus c, what's left? What's the 5 become? -5.
Plus C.
And what's the -c become?
Plus C.
Plus c. Hey. Watch. Anybody see?
They're the same.
What are them? Aren't those the same exact thing?
Yeah.
Yeah. Now we have common denominators, don't we? That's not okay. So when you see the opposites in the denominator, just take a -1 from one of them, and you'll end up with common denominators. So, what is the common denominator here?
C minus.
Okay, I got c minus 5, but you better be careful because there's still something left over here. The c minus 5s are in common, yep, but you need to represent everything. And I haven't represented everything yet. The c minus 5s are in common and a -1, however you want to write that. There's your common denominator. The c minus 5s are in common, and then I still had to write the -1 that was left over. All right. I'm hoping this isn't too bad from here now. What do I still need to multiply the first? Look at the denominator and your common denominator. They're not the same. What do you need to multiply top and bottom by now to make them the same?
-1.
That -1 that was missing. So instead of writing 3c on top, I'm going to write -3c. Denominator of the second one, common denominator.
-1.
I already have the -1 though,
So 1.
right? Look, I got c minus 5 and I got the -1. Is it missing anything? No. So if you want to write 1 and 1, that's fine, or nothing. I'm still adding now. What do I still need to add? 15. If they're opposites, take a -1 out and you'll have common denominators. Anything you want to still do, or we're done?
Take out a -3.
Wish you were done, right? GCF on top. Yep. What's the GCF I can take out?
3. -3.
-3. Okay, if I take out a -3, what's left? 14. Emma?
C minus 5.
Oh, perfect. Look at that. GCF. All right, finish it now. Finish. So you can go on your own there. Finish that for me. Go ahead, Connor. 7.
Cross out.
Go ahead. What?
C minus 5, C minus 5.
What am I left with?
-3 over -1.
Get big boy here for me. I don't want to leave that as an answer.
-3. Right?
-3.
Yes.
Negative divided by a negative.
Oh,
+3. That's the only thing I'm going to worry about is when you have opposites in the denominator, take out the -1, and then you'll have common denominators now. Yes, Jeremy, question? Sure. Anybody else questions? All right, let's get rolling. Moving. Moving to the assignment. Gave you more line paper. Books are up here if you need them. Use your online textbook if you use it. Nope, just go.